Okay, today we're going to be looking at some more Year 13 pure trig work, what I call Pythagorean identities. You've seen one of them in Year 12, and we'll mention that in a moment. But let's look at a couple of definitions first of some new functions we're going to be looking at today. These three here, sec x, cosec x and cot x, short for secant, cosecant and cotangent, although you never really need to know that. These three are called reciprocal functions. Sec is 1 over cos, cosec is 1 over sine, and cot is 1 over tan, which is the same as tan is sine over cos. When I invert it, cot is the same as cos over sine. I tend to remember it because obviously you would think that one cosec has got cos at the start, but it's actually 1 over sine. It's always the reciprocal of the third letter, so 1 over c, 1 over s, 1 over t, like that. Okay, so these three things here, and we'll tend to write them like that. We've got to be quite careful with our notation. Notation of trig things is a bit of a mess, to be honest. When we're looking at powers of cos, for example, cos x times cos x, we write cos squared x. We write the power between the cos and the x, so it doesn't get confused with cos of x squared, which is a different function. We tend not to, though, do the same thing for these reciprocal things. If we did the same thing, we'd write cos of x all to the power minus 1 as cos minus 1 x. But we already use that as an inverse function notation. That's when we're going from y equals cos x, and then we want to do the inverse cos to get back to what y is. So we just write them as 1 overs. This is the only real way we're going to use it. But now we've got these three new functions, we can now generate two more Pythagorean identities. From Pythagoras' theorem, c squared equals a squared plus b squared, in year 12 we derived this one, cos squared x plus sine squared x equals 1. Now, imagine taking this thing and dividing all three terms in that by cos squared x. Well, what we get is another equation. On the other side, the 1 over cos squared is sec squared x. And on this side, cos squared over cos squared is 1, and sine squared over cos squared is tan squared. So this becomes sec squared equals 1 plus tan squared. Similarly, if we take our original Pythagorean identity and divide everything by sine squared, we get 1 over sine squared on this side, and that's cosec squared. On this side here, cos squared over sine squared is this function for cot, all squared, and sine squared over sine squared is 1. So we tend to say it as cosec squared equals 1 plus cot squared. So it's similar to the one above. You will need to learn these. These are not given in your formula books. So let's have a look at how these things are used. I'm going to look initially at just using the three reciprocal functions. I've got a quadratic equation here to solve. Cot squared theta minus 3, cot theta plus 2 equals 0, where theta is in degrees, lies between 0 and 360. Now the chances are, I'm expecting, because it's quadratic, to get two solutions, and because it's 0 to 360, each of those generating two more solutions. So I'm expecting 4 answers in this case here. So let's have a look how I'm going to go about it. Because it's a fairly straightforward equation, I can see the factorised version here. Sometimes what you might want to do to simplify your working is let a letter stand for the trig function and then just factorise it or solve it however you're going to do it. So, you know, C for cot, S for sec, maybe even C for cosec, if it's just the one thing involved like it is here. But in this case I can just factorise it straight away. Cot theta minus 1 times cot theta minus 2 equals 0. So cot theta equals 1 or 2. So tan theta is the inverse of that, 1 or a half. And then I can get two answers of tan theta is 1. I know that in degrees I've got 45 degrees, and add 180 onto it, 225 degrees. And then calculator, trying to avoid writing on my wall. Calculator to do, make sure it's in degrees it is, shift tan 0.5, bracket equals 26.6 degrees. And then feeling lazy, add 180, 206.6 degrees. And that's my 4 answers, all in degrees there, and that's what I expected before pressing buttons. It's always a good idea to consider potentially how many solutions you might be getting. Example 2. I've got a quadratic again, simple quadratic in this case, cosec squared x equals 2, x is between 0 and 2 pi, which is in radians in this case here. But I'm hopeful when it's in radians we get a lot of answers than our standard angles, as we'll see in a moment. Because it's just cosec squared, well, I'm going to be square rooting. That automatically leads to 2 solutions. And in this case, because it's the equivalent to 0 to 360, each of those is probably going to lead to 2 solutions as well. I'm expecting yet again 4 solutions. So let's have a look. First thing I'm going to do, the order of this is irrelevant. You can either square root first and then do the reciprocal, or do the reciprocal and then square root it. So I might want to do sine squared x equals a half, and then sine x equals plus or minus 1 over root 2. So it's going to be standard angles in this case here. So x, from the positive 1 over root 2, it's 45 degrees as above, so it's in radians of pi over 4. To get the other one, the add up to pi, so I'm going to get 3 pi over 4. There's the second one, 45 and 135 degrees. For the minus, it'll be minus 45 degrees, but I'll have 360 on to get, in radians, 7 pi over 4, and the other one, 5 pi over 4. There's my 4 answers. 2b is a change of function. It's got co squared, 2x equals 2, x is between 0 and pi in this case here. So what it means is that 2x lies between 0 and 2 pi. What we've basically got from above is 2x is all the answers that we had before. So I can say that x is going to be pi over 8, 3 pi over 8, 5 pi over 8, and 7 pi over 8. There's my 4 solutions for that one there. What's happened for this function, and we'll come to that in a different chapter, we've seen it at GCSE, what does the 2x do? It concertinas everything. So we're going to get, in the same range, if I'd have extended it to 0 to 2 pi, in this range here, I would have got 8 solutions rather than 4, because I've concertinaed everything by a factor of 2. Let's have a look at a couple more then. We've got the same sort of idea, a nice straightforward function, but in this case I've got a change of function here. It's 2x minus 10 in brackets equals 4. I can rewrite it as sec is 1 over cos, so cos 2x minus 10 equals a quarter. And because I'm changing the function, it's probably worth changing the range of values I'm going to be looking at here. Okay. If x is between 0 and 360, I should be getting 2 answers here. Because of the 2x, I'm probably yet again expecting 4 answers. So let's have a look what happens when I do this. So 720 minus 10, 710. So I've got all these values. Any value for 2x minus 10 that lies between minus 10 and 710, I can then undo the function to get my x values. So press my buttons to get the first one. Remember, the calculator will only give you your first answer. Shift cos 0.25, 75.5 degrees. To get my second answer in 0 to 360 for cos, it add up to 360, so 284.5. And because I've written this, I know I need to extend my range of values, so I can do 360 plus my 75.5, 435.5 there, and then 360 plus my 284.5 equals 644.5. And in that case there, I've got all my 4 solutions now that lie between minus 10 and 710. Adding 360 onto that one gives me 700 odd, nearly 800. And now, I can now go on and solve the thing. So x, I need to add 10, 85.5, divided by 2, 5.5 something, 42 point, rounds up to 42.8. Okay, 284.5, add 10 to 94.5, divided by 2, 147, it would have been rounded down, 147.2, and then so on and so forth. So the 435.5 becomes add 10, divide by 2, 222.8, and then 147.2, oops, 327.2. So my 4 solutions in the 0 to 360 range. Notice, yet again, just as we did earlier on in the course, rewrite your range so you're not missing out on solutions. Fourth example. Now, this is where we're going to be using our Pythagorean identities. We've got a quadratic equation, but in 2 different functions. It involves sec and it involves tan. So I want to get it so it just involves one of the functions. So I'm going to be using the sec squared equals 1 plus tan squared. And in this case, because I've got the tan singular, and what I want to get rid of is the sec squared one. So I can use 1 plus tan squared x minus tan x equals 1. And this is nice because the 1's cancel out. I get tan squared minus tan, or tan x minus 1 equals 0. So tan equals 0 or 1. Off and running really. I've got it in terms of tan. I can then solve it. 0 to 2 pi x will equal, for the first one, 0 pi or 2 pi, and for the second one, pi over 4, and add 1h onto it, 5 pi over 4. So strangely I've got 5 solutions in this case here. I'm checking that there's equals involved there and there, so all those 3 are valid, and those 2 for that one. So notice I've got to take one of the things here and use my Pythagorean identity and think to myself, because I've got tan x, and I can't rewrite tan x as anything else, but I can substitute for sec squared equals 1 plus tan squared, get my equation in one variable, then solve it. I guess in the last one, same sort of idea. I've got a cot squared, I've got 3 cosec plus 3 equals 0, only 0 to 180. I might still, even though it's a quadratic, get 2 solutions. There's a possibility of still looking at 4 answers all in all, and we'll see why in a moment. So I'm going to do my substitution for cot squared. I know that what I had before, I'll rewrite it again. Cosec squared theta equals 1 plus cot squared. So because I'm substituting for cot squared, I can rewrite that as cosec squared theta minus 1 minus 3 cosec theta plus 3 equals 0. There's my equation I'm going to be solving. So cosec squared theta minus 3 cosec theta, and then plus 3 minus 1 plus 2. It's very similar to an example we had earlier on, I think. So I've got minus 2 and minus 1 equals 0. So cosec theta equals 2 or 1, or sine theta is a half or 1. Now, because it's 0 to 180, sine being positive, this one's going to give you 2 solutions in the 0 to 180 range. This one's only going to give me the 1, so I'm only going to end up with 3 answers in the end here. So inverse sine of a half, 30 degrees, adds up to 180, there's my second answer. And then if you think about how a sine goes, the only value from in that range where sine theta is equal to 1 is when theta is 90 degrees. So notice yet again, I've got to use my one of my new Pythagorean identities to do a substitution, and at the moment it's probably not a bad idea for you to rewrite the ones you are using, so it gets you used to learning them. And then from that, get your quadratic in terms of one variable, solve it, turn that into answers for sine, cos or tan, and then do your previous work to remember to get all your solutions. And that's that.